Algebra 2 with Mr. Clausen. Today we are going to talk about simple algebraic equations and mainly how to solve them. So in this lesson we're going to talk about solving simple algebraic equations that just contain a variable on both sides, algebraic equations that involve the distributive property, and then at the end of this video we'll talk about how to solve an algebraic equation by singling out a variable. And so without further ado, we're going to get started here so that we can look at examples and show you guys how to do this. So the main thing with an equation, it's different from an expression in that an equation has this equal sign that separates two components, all right? And if I'm going to go solve an equation, generally there's going to be a variable and some constants. So the first thing that I'm going to do is look at this and go, all right, I need to get all of my variables on one side of the equation and all of my constants on the other. And you just pick what side you're going to do. Usually I put the variable on the left-hand side and the constant on the right-hand side. There's no right or wrong way to do that necessarily. But with this given example, I see that a is my variable, so everything that contains a variable is going to be on this side. So the 6a stays, but the 4a over here needs to move to the other side. All right, and then those guys would cancel out. 6a minus 4a is going to be equal to 2a. All right, and then what I'm going to see here is that I have negative 5 and 2. Well, negative 5 is a constant, so I want to move that over to the other side by plugging in its opposite. All right, negative 5 plus 5, those would cancel. 2 plus 5 is going to equal 7. All right, and then once we get that, we can then go and divide both sides by 2, get a all by itself, and see that our answer is equal to 7/2 or 3.5, depending on what your preference is. Now, one thing I want to just remind you guys, whenever you're solving an equation and you're thinking about maybe like PEMDAS or something like that, is make sure you do all your addition and subtraction work that you can do before you move on to your multiplication and division. Don't start mixing back and forth unless that's what you need to kind of progress forward through the operation to get to the addition and subtraction stuff, because you don't want to start dividing, by 6 here to get a by itself and then move stuff around. Do the easy addition and subtraction stuff before moving on to multiplication and division if it's there. All right, so now let's say we have a situation where we have to solve an algebraic equation using the distributive property. So in this given case, we see 6 and then in parentheses t minus 2 equals 2 times in parentheses 19 minus 2. And in this given situation, this would be an example where there isn't any addition and subtraction work. So I'm just looking at this and I'm seeing it's not there initially. So I have to go and apply the distributive property here and distribute accordingly here. So in this case, we would have to distribute. But once you do this, then what you should do is switch back to your addition and subtraction that you can do, right? Pick a variable on one side, pick a constant on the other. My general habit is to put the variable on the left-hand side and the constant on the right-hand side. So what you should be seeing here is I'm just applying opposites to where things need to be canceled. Those would cancel. I have negative 12t equals positive 8. Right? And if I divide both sides by negative 12, there's no other work I can do here, so this is the next step. T would simply be equal to negative 2/3 once it's all simplified out and done accordingly here. Okay, so hopefully you can see a little bit about how this works out and how that can be done in this given circumstance. Another example I want to point out here is solving algebraic equations by singling out a variable. All right, this is probably where some of the real world application would come in. So this is actually an equation for figuring out the area of a triangle. But let's say, you have this general equation, the base and the height of the triangle. Well, maybe you want to rearrange the equation in some way to figure out what the height is based on its base and its area. Maybe you have that information. So there's a lot of power in being able to rearrange these equations accordingly based on what you have. So the trick here is that, well, if you want to single out a variable, you'll see it labeled like this, where they'll give you an equation, and then the comma here for h is just saying, let's solve this equation for h. All right, so it's h equals something. In order to do this, what you're going to do is get h all by itself. Well, in order to do that, I'm going to rewrite it over here so that we have a little bit of space to work. But if we go 1/2 bh, the first thing I have to do is just start doing things to cancel other things out. So like the 1/2 here. Well, I need to put the reciprocal of 1/2 in order to cancel out. So I'm going to multiply this by 2. But whatever I do to this side of the equation, I have to do to the other side of the equation. All right? And so it mathematically carries through. So these guys would cancel out, and then I would get 2a equal to bh. I divide this side by b to get rid of the b, but I have to do the same thing to the other side. The b's would cancel, and then if we want to rewrite this, it's just 2a all over b. And that's how we would solve for h in this given circumstance. All right. So the last example I want to talk with you about before I conclude this video is looking at a little bit more difficult example with a fraction, and the variable that we need to solve for is in the denominator. Now, in this given case, what you should see is that it wants you to solve for x and also to state restrictions. All right. So whenever you're thinking about a restriction is just simply a situation where you can't have something equal something else, or the function will not be defined. So for example, if you have 0 over 1, you know that this is equal to 0, and this is a real number. This is something that is quantifiable. But if you have something like 1 over 0, okay, this is undefined and is not possible. It equals infinity theoretically. And so these are situations, at least at this level of mathematics, that we're not going to deal with. All we're going to do with this level of mathematics is just say, this is restricted, we can't do this. If you go on and take calculus, you'll talk about that a little bit more, but at this level, all we're going to do is state restrictions. So in this particular case, if we are going to state a restriction for this given situation, x cannot equal a, all right? And stating a restriction is just as simple as saying x cannot equal a. That is our main restriction here, because if x equaled a minus a would be 0, and then you would have a situation with an undefined value. Okay, so anytime you have a denominator of 0, you're going to state the restriction. And you have to look at any point in your equation where a restriction might pop up. So as we're solving this, we might have another situation where we can't have something equal 0. You could also say that x minus a cannot equal 0. That would be an acceptable way to state this restriction as well. All right, so how do we solve this equation and single out this variable? Well, we got to get x in the numerator if we're going to have any shot of dealing with this. So the first step whenever we're trying to solve an equation like this and single out the variable is I'm going to rewrite it down here so I have a little bit more space. But the first thing I'm going to do is, since I don't want to deal with the fraction is really annoying, I'm going to go x minus a, and I'm going to multiply both sides by x minus a. And what this will allow me to do is I can just simply cancel out these components, and then I get a minus c equals m times x minus a. And then what this will allow me to do is go and distribute this as needed, because there's nothing else I can really do at this point. The x is trapped in here. I can't magically isolate it without undoing this factoring out that's here. So I'm just going to distribute, and then I'll say a minus c equals mx minus ma. All right, and now I can do a little bit more work here where I add ma to both sides, and then I would have, let's see, let's go ma minus a, sorry, plus a minus c equals mx. And now all we have to do is divide both sides by m. All we have to do is divide both sides by m, and then we'll see that the m's cancel here, and we'll get our final answer of x being equal to ma plus a minus c all over m. And so with this given circumstance, what we will see is that one other restriction needs to be mentioned here, and that restriction is simply that m cannot equal 0. So make sure that as you're going through this process, you state the restrictions that are present at the beginning equation and also at the end equation and any step in between. All right, so those are your restrictions, and this is how we would solve for x. One additional example that I want to go through with you guys before I conclude this video is an example where you have to factor out the variable in which you have to set it equal to. And I'll go through this example showing you what I mean by that. But in this specific situation, what you're going to notice is that there's an x variable here and there's an x variable here. And I can clearly see from this example that the coefficients or the constants associated with them are going to be quite different, and there's a little trick where you have to factor it out that I want to show you here. So if we have an example like this and it says solve for x and state any restrictions, the first thing that we have to do is what we would normally do. We'd have to get our variable of interest on one side and everything else on the other. So if we do that here, what we have to do is distribute accordingly and use the distributive property to get these things separated. So we'd have 3atx minus 2ab equal to cdx minus 2c. And in this given situation, what you're going to notice here is that there's an x term here and an x term there. So let's just move cdx to the other side. So I'll subtract cdx from this side and then add 2ab to the other, add 2ab. And all this is going to do is get the 2ab's out of the way here, the cdx is out of there, and then we'll have 3atx minus cdx, and then set that equal to 2ab minus 2c. Now I'm looking at this situation and I'm going, oh gross, how am I going to get this x out of here? Well, we use the distributive property to combine this in, but we can go backwards and use a factoring technique, which is the same thing as distribution, only backwards. So how you do that is you just say, all right, if there's an x in both of these terms, we can pull the x out in front, and what we can do is just say x, and then in parentheses, everything that's left other than the x, 3 to the at minus cd. Because what you're doing here is that if we did this distributive property here, we could then recreate what we had before. And then you'd have 2ab minus 2c. And we singled out a specific variable. And if we divide both sides by the part that's in parentheses here, our final solution should be 2ab minus 2c all over 3at minus cd. So with that said, I hope you found this video helpful and you got some useful skills from it. And with that said, let's do some math.